was going to be a dark day no matter which way it went, so. Less Mickey Mouse one than.
Gary Johnson. Full Bernie, free college. Gary Johnson.
You don't want college to be free.
Oh, yeah. Then.
Because it weeds out people you don't want there. You want to pay a little bit of something. What? Yeah, I would probably.
You can't take over Obamacare.
What'll be interesting to see is what happens with the Common Core. So I think they'll throw it to state control, and we'll probably still have to do it. So.
I'm gonna be the next one.
You're gonna be the next one? Yeah. I'd vote for Ivan.
Vote for Ivan.
Yeah.
2045. 2045.
All right, let's get going on this. So we have we're going to talk about graphing these things today. All right. We're going to probably do the first 8 examples. We're not going to do the slant asymptotes. Okay, we decided to cut that out this year. If we've got time, we might go in and do 13, 14, 15. We'll see how our time goes, though. Okay. Mostly, you have to get this to a point where you can recognize the graph to take the test on it. Okay. So I'm going to give you a couple minutes, fill in all the blanks. There's a lot of blanks today, so fill in all the blanks. Give you about another minute or so to finish filling in the blanks. All right, so the good thing to go do when you get lost in your homework doing this is obviously to go back to the box because it kind of steps it out for you. Okay, so you can maybe remember what we did. So we're going to simplify f if possible. Any restrictions on the domain of f not in the simplified function should be listed. So basically make sure you write down your holes. Okay. You're going to find and plot any y-intercepts by evaluating f of 0, which is not something new. We did that with our polynomials. We're going to find and plot the zeros by finding the values that make the numerator equal to 0, which we did yesterday. We found zeros yesterday. We're going to sketch vertical asymptotes by finding the values that make their denominator equal to 0, and plot any holes using an open circle. Find and sketch any other asymptotes. So we could sketch some horizontals. Like I said, we're not going to do the slants. Plot at least one point between and one point beyond each x-intercept and vertical asymptote. And then we're supposed to use smooth curves to complete the graph between and beyond the vertical asymptotes, excluding any points where f is not defined. All right, let's try it. Well, the first few are just shifting stuff, okay? So that's the good news. It says use a graphing utility to graph x over 3 and the function g in the same viewing window. Describe the relationship between the two graphs. All right, so let's do that. So everybody's on your calculator. So I'm going to go to my scratch pad here. All right, and it said we were supposed to put in x or 3 over x. So we're going to do a control divide 3, maybe, over x. And go ahead and hit enter and graph it.
I keep putting multiplex over
All right. And you'll notice on some of the pictures we've seen, some of the older calculators would graph the asymptote. This one does not. You just have to kind of see that it's there. Yes?
I'm sorry, but in the real world, like, what does this mean? 3 over x? X is just a number. Like, is this just showing all the points that it could be?
Yes. Yeah, that's what the graph is all the points that it could possibly be that are true for that function. And remember, you use functions in experiments. You use this stuff here, very relevant to a lot of science applications. Okay? All right, especially the positive branch there. All right, so everybody got that in, right? So now you're going to hit tab again, and I want you to go to your second graph. Why is it not going up? So you're going to go to F2, and it wanted us to add 2 to the F1. So we're going to go to var F1 of x. You're in F2. You're gonna hit the var button and hit the F1 and put an x in there, and then we're gonna do +2 and see what happens to the graph. So basically what you just told the calculator was take the original function, add 2 to it, and hit enter. What happened?
It shifts up too.
Yeah, it shifted up 2. So here's what you're gonna do. Sketch it into your notes really quick. That's your proof that you did it for me. Because you could do this in, Desmos, right? So you could do it in Desmos. You do the same thing. But make sure in Desmos you label it as an f of something function, right? When you type in your original. So then you can use it in your next one. All right, and then we have to write down what happened. And so we're going to describe the relationship is that it shifted up 2. All right, we got it? No? Give you a second and a couple more seconds to get it sketched and shift it up 2, and then let's do the next one. All right, the same parent function, right? But this time I have to do x plus 4 in the parentheses. So let's see if I can do that without doing doc B. So I'm gonna hit my tab key, and I want to go back up to my second one again. Okay? Let's delete off the x plus 2, and we're supposed to put the x plus 4 on the inside. Oh, thank you. Yeah, if you put it on my desk, that's probably the best. You're awesome. All right. What happened this time? It went to the left. And this shouldn't be a surprise to us. We've seen graphs do this before. So again, your proof to me that you did it is that you sketch a picture. All right, Mrs. Ballard loves sketching. Oh, there it goes. There's my sketch. I know, I like winning. All right. I can't win at home because I've got a 4-year-old right now and he has to win everything. The poor 8-year-old cries when he has to win all the time. All right, so we said that it shifted left 4. All right, looking at the next one, let's see if we can predict what's going to happen. What should the negative in front do?
Switch the graph upside down.
Yeah, it should flip it. It should reflect it. So let's try that. So let's prove it to ourselves in the calculator. So we're going to go to our calculator. I'm just going to edit F2 again, okay? So I'm going to take out the x plus 4, and in front of this thing, I'm going to put my negative sign. And then hit enter. Technically, it looks like it could have reflected either way, right? But it should have been a reflection in the x-axis is what is official, okay? So we would write down, oh, I didn't sketch it. I got to sketch it. So sketch it. There's my sketch. All right. And we would say that it was a reflection in the x-axis. So reflection in the x-axis.
If we put y, would we get it wrong?
Probably not. If you had the word reflection, I'd probably be pretty happy. Okay? All right. Let's talk about what's going to happen with this one before we do it. What do you think this 2 in front is going to do to it?
Make it flip. Right.
A flip is a negative.
Move it up too?
The up and down is over here. So we know it's going to shift with this one, right?
Make it, vertical or whatever.
Yeah, it's going to be a vertical. Probably it's either going to stretch it or make it fat, right? Skinny or wide. So the number in front is skinny, right? Let's see what actually happens with it.
Makes it bigger.
Think it's going to make it fatter?
Yeah.
All right, let's see what happens. All right, so let's type that one in. I'm going to hit my tab up again, and I'm just going to type over the top of 2 again. So I got to take that negative off the front and replace it with a 2. And then on the outside, we have to do a plus 1. It's tough to tell, isn't it? Let's take the plus. I'm going to take the plus 1 off. I know the plus 1 shifts it, right?
Yeah.
Looks to me like it's a stretch. Right? It makes it skinny. It looks like it's making it skinnier. Even though it's hard to tell in there. It's not making it wider for sure, right? So I'll put my plus 1 back on, and then we'll sketch it. Oops, not that one. Plus 1. And have my sketch. Alright. So on this one, we would say it was a vertical stretch. Vertical stretch. And it is shifted up 1. In theory, do I really need the pictures to do any of that?
No.
No, you could have done it just by looking at the equation. But it's a new picture for us, and it's good for you to see this picture before we try to graph some of them on our own. So you notice how the rational has 2 branches to it, and they always kind of look, they're kind of a curve. One tends to go up and down, one tends to go, well, they almost look like reflections of each other around the origin, okay? All right, let's try some actual graphs.
Yay.
So examples 5 to 8, all right? Okay, so we're going to sketch the graph of the rational function by hand. As sketching aids, check for intercepts, vertical asymptotes, horizontal asymptotes, and holes. All right, so we're going to use all of those things to help us graph today. So let's start with our vertical asymptotes. Okay? So where do you get your vertical asymptote from?
Denominator.
The denominator. So I take the denominator and I set it equal to what?
0.
0. So I end up with x equals what for my vertical asymptote?
0.
-2. So here's what we're going to do. We're going to draw a vertical line at -2. Because that's going to assist us in graphing.
Oh, and ours is wrong.
What's wrong with yours?
Your x plus 2.
Oh, my. Okay, let me fix it to yours. I'm sorry. I don't know why it's a... Let me do this. Let's just start over. Okay, so I'll make it to a minus. I apologize. All right, so it's a -2 there. So you have your vertical would be x minus 2 equals 0. So x equals 2. Is that right? Okay, so let's do a vertical at 2. We'll match what's in your book. I don't know why it's typed wrong like that. All right. To get a horizontal, remember we look at the exponents. So what do you notice about the exponents?
That one 0 and that one.
Yeah, so which one's smaller, the one on the top or the one on the bottom?
Top.
Top. So when the one on the top is less than, do we remember what the horizontal is?
There's none.
All right, I want you to flip back a couple pages in your notes and look at the chart.
Y equals 0.
Everybody flip back and look. Make sure you know where to get the information from.
I always forget.
So if it's less than, what do we do?
Y equals 0.
Y equals 0. So this is, it's sometimes, I'm going to try to trace it on there in red. That's why I left it in red, because it's easier to see on the black. Okay. Now we need to talk about the so we've done vertical, we've done horizontal. There weren't any holes, right? So I didn't have holes this time because there was nothing to cancel. I need to check for intercepts. So to check for intercepts, I look at my y-intercept, and that means I just plug 0 in. Okay, so I'm going to take 0 and plug it into my function. So 3 over 0 minus 2. So what is that end up being?
3 over negative 3 halves?
Yep, which is the same as negative 1.5, right?
Yeah.
So I know that on there I have a dot at my 0 is at negative 1.5. So the good news is I know that there's a branch down here and a branch up here. It's probably a good idea to pick some other numbers and try to get it a little bit more precise. Okay? So I'm going to do a little t-chart. Let's see if we can figure out how to pick numbers. So I get to pick my x, the y comes out, or the y value comes from me plugging into the function. Okay? So I've already got one x value over here. I got the 0. I want to pick another number on the left side of my asymptote. So what would be another number that's on the left side of the asymptote?
1.
1 would work. Okay, so let's put 1 in. Well, we've got 3 on the top. What is 1 minus 2?
Negative 1.
Negative, no.
1 minus
Oh, 1 minus 2, you're right. Negative 1. Sorry, I was looking at the wrong answer here. So we've got 3 over negative 1 is going to be what? Negative 3. So I know I'm going to have another point at 1, negative 3. So we know an asymptote looks kind of like a curve, right? So the way, as long as you've got a couple of points to guide you, use the asymptotes to guide you as well. We get as close as we can to the asymptote, we curve it when we hit our points, and we get as close as we can to the asymptote. That was the first branch. I know my second branch is going to be up here. So I'm going to pick some values for that. So now I want to pick values that are to the right of my asymptote. So what are some numbers that are to the right of the asymptote?
3.
3 would work. What else?
4.
4. Perfect. All right, so I'm going to do 3 and 4. I'm putting in, I've got 3 on the top. What is 3 minus 2? 1. So I know I've got a point at 3, 3. So I'm going to go out 3, up 3, and get a point. I'm going to put in a 4. I know I've got a 3 in the numerator. What's 4 minus 2?
2.
2. So 3 halves is the same as 1.5, isn't it?
Yeah.
So I know I've got a point out 4 and up 1.5. And to sketch my smooth curve, I get as close as I can to my asymptote. I curve it and get as close as I can to my asymptote. Yes.
What are you using to solve the x?
To solve the x, I'm going back here into my original equation.
Oh, okay.
Okay? And remember, I picked my x's by going to the values to the left of my asymptote and then values to the right. All right, we good with example 5? All right, let's try example 6. All right, so same idea. I would probably want to start by asking myself, is there anything that cancels? Can I cancel anything in this one?
No.
No, so we've taken care of the holes, right? Nothing canceled, so there weren't any holes. All right, next thing I'm going to do is my vertical asymptotes. How do we get vertical asymptotes?
By setting it equals 0.
Set the denominator equal to 0. So I'm going to sketch that vertical asymptote. We get basically the y-axis this time. All right, let's talk horizontal asymptote. So horizontal asymptote, I start by looking at the exponents. What do we notice about the exponents? They're the same. So how do I get the horizontal asymptote?
What's that?
The leading coefficient. So I do y equals 2 over 1 or just 2. So I'm going to draw a horizontal asymptote at y equals 2. Notice I draw my asymptotes as dashes, right? Because they're really not the official graph. They're helping us guide where we draw the graph. All right. So in this case, there is not a y-intercept, right? Because there's an asymptote on the y-intercept, but there might be an x-intercept. To get an x-intercept, you set the function equal to 0. So you put 0 in for the y value. Let's see if we can find an x-intercept. All right, so when I multiply x times 0, what do I get? 0. So 2x minus 1 equals 0. And then what are we going to do to move that 1 to the other side? And then what are we going to do with the 2? Divide. So I know that there is a point at 1/2, 0. So I'm going to go out 1/2 and up 0. I know that's part of one of my branches. So I need to pick some numbers to get the other pieces. So I'm going to have x, and I'm going to pick, and I'm going to calculate f of x. So since I'm already working on the right branch here, I might as well finish the right branch. What would be a good number that's to the right of my asymptote to plug in? 1? Is that good? So if I put a 1 in here, what's 2 times 1? 2 minus 1 is 1 over 1 is 1. So I have the point 1, 1. And that's enough to probably graph it. So I'm getting close to my asymptote. I'm going to curve it. That's awful. It shouldn't have a little dip in there. Okay. I now want to pick a couple points to the left. So what are some good points to the left?
-1.
What else?
-2.
-1, -2. Perfect. All right. So what is 2 times a -1?
-2.
-2 minus 1. -3 over the -1 is going to give me what?
3.
+3. So I'm going to be out -1 and up 3. Shouldn't surprise us that it's going up in that top left-hand quadrant, okay? Because they usually are in opposite quadrants. Yes. All right. And then we're going to put a -2 in. So it's 2 times -2? -4 minus 1 is? -5 over -2 is going to be +5 over 2, which is really 2.5, right? 2 goes into 5 twice with 1 left over. So I'm going to go out -2 and up 2.5. Something happened. 2.5 is here. I was going up 3.5. All right, so we get as close as we can to our asymptote, curve it, and then get as close as we can to the asymptote. There's your rational function.
This lesson's so hard.
You think it's hard? I don't think it's that bad. It's tedious. It's not hard. There's a difference. All right, let's skip 7 and do 8. Okay, because 8 has a lot going on in it. All right, so first thing I'm supposed to do is factor if I can. So let's do some factoring on this thing. What's the numerator factor into?
X plus 3, x minus 3.
Good. All right, the denominator is going to factor, let's see, I've got 2 numbers that multiply to -3 and add to 2.
-3.
Good.
1.
So x minus 3 times x plus 1. What's going to happen?
Cancel. cancel.
When I cancel, what do we consider that?
Whole.
A whole. Okay, so let's write down our whole.
A whole.
A whole would be at x minus 3 equals 0 or at x equals 3. Here's what I'm going to do. I don't know where I'm going to have to graph that yet, so I'm just going to, above 3 on my graph, draw a hole and know I have to add that in somewhere. Okay, that kind of is a reminder to myself. So the function we're actually graphing is x plus 3 over x plus 1. So now let's go for our vertical asymptote. So for my vertical asymptote, what do I have to do?
Set it equal to 0.
Set what equal to 0? The denominator equal to 0. So we get x equals what?
-1.
-1. So I'm going to go to -1 and draw my vertical asymptote. All right, my horizontal asymptote, we got to look at the exponents. What do you notice about the exponents? They're the same. So what do I have to do to get the horizontal asymptote? The leading coefficients. What are both the leading coefficients? 1. So I know my horizontal is at y equals 1. All right. It looks like I could get both an x-intercept and a y-intercept this time, huh? So let's try that. That'll at least get us some of the points. So to get the y-intercept, I plug 0 in for the x. So I'm plugging 0 into this. I can plug it into this function right here. Actually, let's see. Yeah, we can plug into that function. We should be fine. So we put 0 in. We get 0 plus 3 is what? 3. And 0 plus 1 is? 1. So you end up with 3. So out 0, up 3. Would be right there. Oh, I should do a different color for my actual graph. Let me do that. Let me find one that's going to show up a little better. So right there is my at y-intercept. I'm also going to calculate my x-intercept. My x-intercept says we set the whole thing equal to 0. What's going to happen when I multiply x plus 1 times 0? It cancels. It's 0. So you get x equals what? -3. So your x-intercept is -3, 0. So I'm going to go out -3 and up 0. There's my x-intercept. So the good news is I've already got a point on each branch, don't I? So in my t-chart, I really only need to find 2 other things. So let's see. We've got x and f of x. All right, so let's see. If we're going to go to the right side here, what would be a good x value to put in? 1. Okay, well, we're at it. When I go to the left side, what would be a good x value to put in?
-3.
We already have -3. How about -2? Does that work? Okay, so here's what I want you to do. You can plug into this. So I want you to find both 1 and -2, evaluate it, plop it on the graph, and see if you can get yourself graphed. Okay, but watch for the hole. So I'm going to give everybody a minute to try it. Calculate your 2 values. It's not too hard. All right, let's check it. So we put in a 1. What's 1 plus 3?
4.
4. 1 plus 1 is 2. So I have to plot 1, 2.
Yes.
So out 1, up 2. Sketch that branch. Oh, but what do I need to make sure I put in there?
Hole.
A hole. So I'm going to go to where my graph was at 3, and I'm going to make sure I have an open circle right there. Okay. I'm putting in -2, and let's see, what's -2 plus 3?
-1.
1. -2 plus 1 is? So my answer is So out -2, down 1, no holes to deal with on this side, so it looks like this. Okay. Let's take a look at, we're going to skip a whole bunch, okay? Let's go down to, let me find it. Yeah, we're not going to do the slants, but there is another little piece in here. Let's try example 14. Okay? Alright, if we at least do 14, you'll be able to get to the homework here, okay? So we're supposed to use the graphing utility to graph the function, determine any x-intercepts, set y equal to 0, solve the resulting equation to confirm your results. So let's use our calculators to our advantage right now, okay? So again, you could do this in Desmos, right? So let's go ahead and let's type that function into your calculator right now. So I'm going to clear what's there. We don't need what's there anymore. All right, and we are typing in, I'm going to do a control divide, and I'm going to do 2 over x plus 1. And then that was added, or it's subtracted. I'm going to hit another control divide. 3 over x. And you can go ahead and look at the graph. All right, what it wants me to do is to find any x-intercepts. That was what the instruction was. It looks like, and you see this one's weird, isn't it? See how this one here looks like it's kind of, it looks like the x-axis is the, is the horizontal asymptote, but over here it looks like it shifts a little bit because it looks like that's above the x-axis. So that happens once in a while, and that was because this function wasn't just a typical rational. All right, so let's go here. We go to menu. Do you guys remember how to find zeros?
Yeah.
What do we have to push? Analyze graph and then 0. And then we're going to go to the left of it and to the right of it, and there's our 0 pop up. I don't think there's a 0 on this side over here. If I kind of pull this out, oh, look at that. It never goes, doesn't look like it ever really goes. It looks like it's right on the axis, doesn't it? If I zoomed way in or way, I would probably not. So I don't think there's a 0 over there. We could try it. Did you try it? This doesn't hurt to try. Look at that. There's no 0 in there, is there? It didn't pop up with one, did it? Oh, no 0 found within specified bounds. So we're going to go with there's 1 0 and it's -3 0. So everybody sketch your graph, show your 0, and then we're going to do this. We're going to confirm it by doing the work by hand. Okay, again, it looks scary. It's not that bad. So, in order to find a 0, we set the function equal to what? 0. Okay, now we've done this rational work before. We don't like the denominators, do we?
No.
So we multiply by the LCD. What's the LCD? X times x plus 1. So multiply everything. X times x plus 1. X times x plus 1. All right, what's going to cancel in the first term?
X plus 1.
Good, and we're left with 2x. What's going to cancel in the second one? X, and we're going to distribute the -3. So you get -3x minus 3 equals 0. All right, what's 2x minus 3x? Next, and I'm going to move this 3 at the same time, so I get +3. So x equals what?
-3.
And your intercept would be -3. Isn't that what we got on the calculator? All right, that's where I'm going to stop. Okay, that should get you enough to be able to do the homework assignment. You're going to look in haiku. I split it into 2 days. Tomorrow we're doing we're going to have the study guide and performance task out. Okay, and then you get the 3-day weekend plus Monday in class to work on those things. The study guide needs to be done by Tuesday. Wednesday we're taking the test. Okay? Any questions? All right. I'm going to hold off on stamping till tomorrow since we've got a whole period where I can stamp. Okay? So you guys have the last few minutes. Make sure your homework's written down.
We have 10.
10 minutes. You could go grab a book.